So if you're seeing my screen, you see, consider the following function. 1, 0 is -1 minus 3i. Use the given 0 to find the rest of the zeros of the given function. So the thing that's interesting about these is that they always come in pairs. So if -1 minus 3i, I shouldn't write it with the x parenthesis there. That's a little weird. It's also -1 plus 3i. This is the conjugate. The equivalent is like if square root of 3 is a solution, then so is negative square root of 3. And to just take that a little bit further, like let's say the solution was 2 plus square root of 3, its conjugate is 2 minus square root of 3. So these always come in pairs. Okay, so the find the conjugate of the complex here. So I guess we can just say -1 plus 3i here. It's always this middle operator that you change. It's never the first term. Now, because it's an odd polynomial, it must cross at least once. Like it starts here and ends here. So it has to cross at least once. That means there's one real zero for sure. There could be 3, but because there's 2 complex roots, it only has 1. I don't know what it looks like, but it crosses somewhere. So what can you be certain? This conjugate is also 0 of f if the original divides it evenly. Okay, so we can certainly do this. Do you want to see this done out by hand, or do you want to believe me and then graph to find the other root, or what's the goal here? And that's, I guess, to Jamie, since you sent this. Oh, I guess you do have to factor it.
Can you repeat that? Sorry.
Well, my question, I guess, is like how much depth do you want in this? Because this is a WebAssign. It's not a it's not like I don't know if you're even doing these by hand, but okay, well, I'll just keep going here. So x, it's always x minus the factor. So for step 2, because this is one root, it's now x minus -1 plus 3i, and that's what they're looking for there. It's always x minus your factor. So if your factor is -1 plus 3i, then it's -1 minus 3i is the other possibilities. Step 3. Find the product of the 2 known factors of f from step 2. Okay, so I think they want you to actually multiply. They want you to say x minus -1 minus 3i, x minus -1 plus 3i. Is that okay?
Yeah, that makes sense.
So you're going to distribute this negative to both. So it's x plus 1 plus 3i. There's other ways to do it, but this is for my preference. X plus 1 minus 3i. And then you just multiply everything. So multiply the first times each of these terms. That's x squared plus 1x minus 3ix. And then you do the next one. So you get an x, you get a 1, and then you get a minus 3i. Then you do the last one here. So you get 3ix plus 3i minus 9i squared. And if you've done this right, all the I terms go away. So see how those cancel. And you do it in a way where you line them up in columns. That's another kind of useful thing to do here. So that gives you x squared plus 2x, and then I squared is -1, so this is plus 9 at the end. And that's your boxed in answer for step 3. Step 4 is to divide f by your result from step 3. So we're gonna take what we got in step 3 here. We're gonna go back to the original. So let me get everything kind of set up here. All right, so this is the original. And then you guys remember your long division. You're going to put this x squared plus 2x plus 9 over here like this. And then you put x here because x multiplies x squared to give you x cubed. X cubed plus 2x squared plus 9x. Then you subtract. I'm going quickly here because this is review. And if it's not, just let me know and we'll spend more time on it. Then you bring the 30 down. So then you multiply to get this 3x squared. So you go plus 3. So you get 3x squared plus 6x plus 27. Why isn't this working? Did I make a mistake up here? I must have. X squared plus x minus 3x, x plus 1 minus 3i minus plus 3ix plus 3i minus 9i squared. Oh, this is 10. That's why. This becomes plus 9 plus 1. Okay, so that's one of the problems here. But all that does is change this one. There it is. So that becomes a 10. And then when you subtract, this gives you 6x. There we go. Okay, now this is working out. So you get 3x squared, 6x, and 30 down here. And see how they all subtract out. It should go to 0. That means this is correct. So this is your step 4 is this box right here, the result of that. And then step 5 is you set the x plus 3 equal 0, so x equals -3.
Got it. Okay. Thank you.
You're welcome. Okay, so Niko, we're gonna move to your problems. Thanks for being patient here. I'll just do them in the order that I see them in, if that's okay.
Yeah.
And we'll go from there. So 7, these are all word problems. I assume you're allowed to use a calculator because you're not in calculus yet, so you don't have a way to do these by hand. All right. So the part A is to show that the solution, or to show that the concentration is this. So the 1,000-liter tank contains 50 liters of a 0.25% brine solution. You add X liters of a 75% brine solution to the tank. Okay, so X liters of a 0.75% solution. All right, so you have a tank like this, and its max volume is 1,000, and it already has 50 liters in it. So this is like a percent times amount plus percent times amount equals percent times amount. Okay, and we know that that it contains 25%, so we'll say 0.25 times 50 liters plus you're adding in 0.75 times X, and the concentration C, that's what that means right there. The amount you're going to have in is X plus 50. So let me know if that's unclear. Let me know. We're going to get rid of these. These are really fractions. This is 1/4 times 50 plus 3/4 times X equals C times X plus 50. So we can multiply everything by 4. So that becomes 50 plus 3X equals 4C X plus 50. Hopefully you're seeing how this works out. You divide both sides by 4 times X plus 50. Okay, so you get C equals 3x plus 50 on top, and then 4 times x plus 50 on the bottom. Maybe the hardest part, I guess, to figure that out. So part B is to determine the domain of the function given the physical constraints of the problem. So going back to the drawing here, x represents how much you're adding in. Like you're pouring in x to this thing. It's already got 50 in it. So x, you can obviously put 0 in, but the most you could put in is 950 because the maximum volume is 1,000. So that's what they mean by determine the physical domain. Like you wouldn't pour, I mean, you might, but it would be unrealistic to pour in more than 950 liters in. So that's your domain. And the reason they want you to do that is because when you graph this thing, you have to see what happens on this interval. Like you don't want to graph it from 0 to 2,000. Is there anything you'd like? Is that clear or anything or not clear? If it's not, let me know.
Oh yeah, that's clear.
Okay, so I'm just going to graph this this original function, y equals, I'll snip in a graph here. So we got 3x plus 50 in the numerator, 4 times x plus 50 in the denominator. I'll snip this graph in here shortly. And then we've got from 0 to 950 on our x. And see the y value, this is what's interesting, your y, because it's a concentration, it's going to go from 0 to 1. So even though you're going out really far on the x, your y is just going up a little bit there. So let me get that in here. Okay, so I've got a nice picture of this. Let me snip this in. Let's see what's going on here. Here's your picture. We talked about like finding the window is kind of the biggest challenge in these questions. So it looks like it's approaching a certain value here. And that value is y equals 0.75. You might be asking, well, how did I know that? It's because it's 3 over 4. And it's just the horizontal asymptote of this thing. That's part C.
So part C is just finding the horizontal asymptote.
Yes.
Basically.
Yes.
Okay.
It says as the tank is filled, what happens to the rate at which the concentration of brine increases? So what they're trying to say is like when you put a bunch in the beginning, the concentration increases really fast, and then it doesn't increase as fast.
Okay.
And then the more you have to put in a lot more to get it to increase by the same amount. All right, 79. Is that okay?
Mm-hmm.
Or do we have one before that? Kind of, Niko, I'm guessing, yeah, just making sure.
Yeah, 79. So.
79 and then 81. Okay.
Yeah, those are.
All right, so just need to download this picture. I'm gonna rotate it and then snip. There we go. What is the end of part C there? Use a graphing.
79.
Yeah, use a graphing utility to graph the area of the function and probably just determine the value.
Yeah, approximate the page size such that the minimum amount of paper will be used.
Okay. Great. So my guess is that the most difficult part of this really is like they're telling you to show that the total area is, and like I can imagine that's the hardest part because like it's easy when the equation's given, you just graph it and find the min or the max. Okay, so they're telling you this is slightly different than that box problem like we did last time. They're saying the width is x and the height is y. So the area of the total thing is xy, Okay, but they actually want the area of the, I guess they want the area of 30 square inches per the margin of the top. Oh, they're saying, I'm sorry, they're saying this is X. I mislabeled this. I gotta read these pictures more carefully. Okay, they're saying this is X and this is Y. So the up here at the top is X plus 1 plus 1. These right here. And then the Y over here. I guess they do give you Y. I'm so sorry. I'm really losing it here. Okay. Page that is X inches wide, there's X, Y inches high, contains 30 square inches of print. Okay, so they're telling you X times Y equals 30. Okay, that's what that means. The margins at the top and bottom are 2 inches. They're labeling that. Left and right is that. Okay. Show that the total area A of the page is given by 2x plus 11, x minus 2. What are they referring to? Okay, so this, I think they're referring to this area in here, which is x minus 2, and then this is y minus 4. So x minus 2 times y minus 4. But they want you to solve this for y. So y equals 30 over x. I guess, but I'm really struggling here. I really have no idea what this is asking for. The total area A of the page. Page is X inches wide, Y inches high, needs square inches of print. Maybe, okay, maybe they mean that this box is 30. Could that be? I'm not sure. So then X times Y. All right. I'm going to the internet, guys, because I really don't know what this is, which image they're referring to. So stand by here. Let's see if I can find someone else who's worked this problem out to help you. Oh, blessed. Okay. I apologize for the delay here. Oh my goodness. They're really. Okay, so this is correct, right? This second line is correct. That when they say 30, they're referring to this inside box. And the page is X times Y. Okay, so they're calling this total area A, which is the page A. So they're saying it's really A. So X times Y equals A. They want you to solve for Y. Y is A over X, and then replace that in here like that. Okay, so that gives you X minus 2, A over X minus 4 equals 30. So the whole page is as A. And this little part, this is the print part, is 30. So now you have to solve for A. And it looks kind of it's kind of tough. You can just move this x minus 2 over. So you have A over x minus 4 equals 30 over x minus 2. Then you can add 4 to both sides. So you get A over x equals 30 over x minus 2 plus 4. Okay. And then it's kind of a choice here. You probably want to make a common denominator here. So common denominator would be x minus 2, x minus 2. And that gives you 30 plus 4 times x minus 2 over x minus 2. And then you multiply both sides by x to cancel the x on the left. So your A, and that's all of this. So your A is 30 plus 4x minus 8 times x over x minus 2. And then your numerator becomes 4x plus 22 times x over x minus 2. And I believe that's what they're looking for. They have a 2x because you can factor a 2 out of both of these. So that's how they get that. So it's x2 times 2x plus 11 over x minus 2. And then this right here becomes 2x. Sorry for the delay on answering that. Hopefully it's clear now.
Can you explain one part of the question?
Sure, go ahead.
Where is it? The x minus 2. Where did
Sure.
you get that part? And
Sure.
not like the rest
So
of the equation.
let me reframe the image here. So a lot of thought, this was very terribly confusing. So x is the whole length here. And this width right here is 1. And this width right here is 1. So to get this width here, you have to take the x, subtract 1, subtract 1, subtract, basically each of those.
Oh, okay.
And then you do the same thing for the y.
Okay.
So this is y minus 2 minus 2.
I see. Okay.
I found this terribly confusing because you're solving for, once I see the solution, it's no big deal, but because you're solving for, because they give you A instead of a number, I think that's where it's kind of confusing. And because like you're not getting anything better, you're putting this back into this horrible equation. So that's part A. Part B is to determine the domain based on the constraints of the problem. So we look at this equation here. One of the problems is you can't divide by 0. So we know like x cannot be 2. So that's one issue. Another issue. I don't know. I guess I don't know how much they want you to investigate this, but if we look at this equation here, the denominator cannot equal 0. So we know that x cannot be 2. That's one possibility. When you look at the numerator, you set those equal to 0. And you find that x could be 0 or x is going to be minus 5/2. So neither of those are kind of interesting, I guess. But if x is 2, when you subtract 2 from it, you get 0 up here. So see this like inner part here is x minus 2, y minus 4. So x has to be greater than 2 because if you put in a number like 2, it becomes 0. So anything bigger than 2 is good. So that's probably your domain. And you would see that on the graph. I mean, I guess that's more important. Like if you're not sure how to determine the domain, you can graph it first and then come back and make up your mind about what it should be. So let me graph this and hopefully it will be clear. You guys are doing so much graphing in this class. which is good, but I don't know if they're going to continue with that for the rest of the course. Seems like sometimes they go away from that. All right, so let me frame this window a little bit better. So 0 to 10, and then that's kind of okay. There's a good point there. All right, so let me snip this in. Let me snip slightly better. All right, so I got a window here to show you guys so you can see what's going on here. All right, so the problem here too is that there's a vertical asymptote when you graph it. So this thing comes down, and this is the X value of the box. But this right here is not the Y value. It's the thing that this represents. This represents the value of A. So to get Y, you don't use that value. To get Y, you go back to Y equals, what was it, 30? You go back to this equation here to solve for Y. So you take this and you say, oh, I know my X is 5.873. You plug that in there, and then you solve for Y. This spread up here is the area of that page.
Okay.
Any questions on that?
Oh, no, I got it now.
Okay.
Thank you.
All right. By comparison, 81 is very straightforward. 81 is simply used to, you're going to graph this thing to determine that point there. So do you guys have your graphing calculators handy?
I do.
Yeah.
Okay. So what I'm asking you, because I'll switch to my graphing calculator now, I want you to put this very carefully into Y1. This is going into Y1. They're trying to help you here with, this is your X min. I don't know what your X max will be. So the main thing here is to try to figure out a window that's reasonable here. And like, that's 1. I don't know what this value is. This is probably 0, but go ahead and give that a try. I'll get my calculator out, and then I'll see if I can help you guys figure out what the right window is. Basically, this curve should come down at some point, and we're looking for that place because it's a min. So it's looking for a min here. All right, let's get the calculator out. I'll just talk here a little bit. In my experience, the main problems come from entering the equation in incorrectly.
Yeah, I noticed like forgot a parenthesis in there.
Yes, and it's just, they call it, user error in programming. You can't account for it, but it's there, it happens. So a lot of students will overdo it with parentheses, and it's fine as long as you get the ones, you think of it as doors opening and doors closing. If you open a door, you better close one. Sorry, missed something here. Plus 30. Parentheses. Okay. I like to go to the window first and try to make a guess before I do this. I couldn't even tell you on the Y, so I'm just going to go up to like I don't know, 1,000. Then I got lucky. Now I didn't go out far enough on mine because this thing's supposed to come back up. And I don't actually need to go that high on my Y. So I'm going to go back to my window and make another guess. So my X max, I'm going to go out to maybe 100 this time. And then the Y max will go, we'll just go 200 on that. There, see how it's kind of coming back up there. Hopefully you guys are seeing that as well. If you go out even further, it'll come up, it'll show more of it coming up. And then I'm writing this down in the notes so you have it, but you want to do a second calc min. Second calc min. Okay. And what most students do is they do a left bound and a right bound. They just trace along here. So here's, I don't know, I'm left of it here, whatever, 26 point whatever. So I'll hit enter. I can just actually enter in a right bound. Like I can hit in like 150 because I know that's way right of it. Oh, it didn't like that. Okay. Let me go. I must have gone way past. Okay, let me go out like 40. You don't have to actually trace over to it, and then it'll guess, and then it'll tell you. That's right at 40. Okay. So the X value, I'm just writing this down. The X value is 40. The Y is not necessarily the Y. The Y represents in this case the cost in thousands of dollars. And maybe it asks for it, maybe it doesn't. But in this case, it actually just wants the order size. So if we go back to our question, the question asks for the order size, but it tells you that it's in hundreds. So you got to be really careful here. Like, and the U of A does this a lot on their college algebra and calculus exams. It's the answer is 40 hundreds, so 40 times 100. Okay, which is 4,000. And they'll say like the answer is between they'll say like B will be like 3,700 to 4,200. So you got to know that number, like you got to know what that is to know that it's, you know, it's answer B because it's between there. All right, Jamie, do you have some other things you'd like us to work on?
Let me look real quick.
Okay, Niko, do you have anything you'd like to look at?
I think that's it for me. Those word problems just confuse me.
Yeah, they're tough.
Not really seeing much. Let me just check my book for any problems we haven't done.
Sure. I've got one from another student that's not in your class or anything, but it's the same deal. So let me pull it up. See if you guys can make some here it is. Pull this up. All right, let me snip this question in. All right. Okay, the Welcome Home Apartment Rental Company has 1,600 units available, of which 800 are currently rented at $300 per month. A market survey indicates that each $5 decrease in monthly rent will result in 20 new leases. Determine the function R of X, that's revenue. Revenue is price times quantity. What is the current price? Circled it. And what is the current quantity? it's 800. So these things work inversely, like one goes up, the other goes down, one goes down, the other goes up. So currently the price is $300. Are they proposing to increase or decrease the rent? Decrease.
Yeah.
Okay. Now, X is the number of $5 decreases in monthly rent. So minus 5X. The quantity is currently 800. And what do they expect will happen? Will it go up or down?
It'll go up.
It'll go up. Okay, so this is your problem. I want you guys to I want you to graph it, and I just want the max, whatever that is. There's a maximum point there, but you got to be very careful here, because what I'm asking for is you're going to give me X and whatever this is, which ends up being revenue. What I really want is the price that someone's going to pay, and that has to take into account this 5X. Okay, so hopefully I've given you enough information. I'm just asking you to graph this, find the maximum point, and then interpret the answer. And if you guys could chat over what you think is the right answer, give you a minute or two to work on that.
Should we round the max to a whole number or no?
The X value is a perfect whole number.
Okay.
Now, if you see something like 0.99999, so on,
Yeah.
you should obviously round that up, or if it's
Okay.
0.00001.
Okay, thank you. And we're looking for the price, right?
Yeah, I want to know what this management planning company should charge.
Okay.
Not the value of X, because the value of X is an intermediate answer. Okay, Niko, so your answer, Jamie,
I'm
take
just typing mine up right now.
Yep, just take your time here. Oh, you gave me both. Yeah, that's great. Yep. Perfect. Both of those are, you guys are on the same answers. So good job on that. When you take calculus, you'll learn how to do this by hand.
Wow.
We didn't talk about it, but the domain of this function that's reasonable is 0 to 60. And here is how we can determine that. If you look at these two equations down here, I'm going to snip them. This first one, when x is 60, it equals 0. And so that's how you know, oh, that's the place where we sort of stop looking. So you might see something like that on your test, like, because all the questions we looked at did have a domain question on it. So
I have a quick question.
of course.
So I'm just not sure. Would it be you said it was 60?
60 is the end of the domain. Like your domain is from 0 to 60.
But would it be 40 if they can't rent out more than 1,600, or does it still remain at 60? That's when the price is 0.
Good point. So you're saying when x is 60, we got a problem here, because that means that this is 1,200, which is way more units than they've got. So actually, x, like you just said, x has to be less than 40.
Got it. Okay.
Because of that. That's actually really good. So this problem is not vetted correctly. Somebody just arbitrarily picked that one. But you're exactly right. It actually would be to 40.
Okay.
It's a really interesting thing. All right. Well, I think that's it, guys. Hope you got everything out of this you needed.
Yep.
Anything else before we close up here?
I think I'm good.
Yeah, it looks good to me.
Cool. Thanks, guys. I'll send you the notes and the screen recording out shortly.
Thank you.
You're welcome.
Thank you.
Bye now.